This exercise should help you learn about linear regression and in particular how to use your TI84 calculator to the best impact. So 2 undergraduates to Cal Poly investigated factors that might be related to the price of college textbooks. We got some variables here. They took a random sample of 30 textbooks from the campus bookstore and recorded the price, one variable, number of pages, a second variable, and year of publication for each book. The data are stored in the file textbook prices. Actually, that's a folder. And these are the 3 files that we have for that. Pages, TXRC, so it's not price, that's a textbook price, and TXYR, that's a textbook year. Which of these variables is the most reasonable to consider the response variable? So I'm not looking for the explanatory variable. I'm looking for the response variable. And again, this is thrown out of the American Association of Statisticians, but which one is more likely to cause the other? So I'm thinking that the one that is the one that is likely to cause would be the explanatory, and the one that is the result is the response. And I'm thinking that the response would be price, because the price isn't going to determine the number of pages, and the price isn't going to determine the year, but the number of pages or the year may have a big impact on the price. So I would say that that is the one that is the most, price is the one that's most likely to be the response variable. And remember that the explanatory variable, the explanatory variable will be your x variable. That'll go on the x-axis, and the response variable will go on the y-axis. So they want me to make 2 scatter plots here. One of price versus pages, and the other of price versus year. Now, one thing that's a little bit confusing to me, and I always have to look it up every year, is that when you have something versus something else, the y value is the first one and the x value is the second one. I don't know why it's like that, but it is. So let's make a scatter plot of price versus pages. So I'm going to call up my calculator. Here's my calculator. So well, I'll guide you through the whole process here. First, I'm going to just clear off whatever it is that I have, and I am going to put these in the 1 and 2 lists. So I'm going to go Stat, Edit, and I find out that my 1 and 2 lists already have some data in it. So I could go to 3, 4, 5, or 6, but I'd like to use my 1 and 2 lists. So I'm going to go up here to L1. I have to get my cursor so that's highlighting L1 and press Enter, and then you'll see the cursor comes down here at the bottom, and I go Clear, and then I hit Enter again, and L1, everything vanishes. So I go over here to L2, and I go up to L2 right there, do it at the top part where it says L2, and hit Enter, then the cursor comes down to the bottom, shows you all the stuff that's in L2 as an array, but I want to clear that. I clear it and hit Enter again, and I have L2. Now, I could have done this whole exercise here using the actual files of price and pages and year, but I find it's a good practice to instead put it into the L1 and the L2, and that way you're able to manipulate the data if you have to, which happens not infrequently. And but if you kind of make a mistake or forget what you manipulated and want to go back to what you had before, then you can just reload the file and you haven't damaged your original data. So I'm going to make L1 the price. So I go up again here to L1, I highlight it, and I hit Enter. And now I'm down here at the bottom. It says, well, okay, you want L1 to equal what? Well, I want it to equal price, so I'm going to go second list, which is right above the stat, and I have a list of all the files I've loaded in my calculator. Now I could scroll down to get to the P's for price, or actually the T for TX price, but rather than do all that scrolling, I'm going to press the alpha button, and then I'm going to press T, and I don't seem to have it. Okay, well, I just loaded it on. So again, I'm going to go Stat, Edit. I'm going to go up to L1. I'm going to enter, so I have my cursor down here at the bottom, and it's asking me what do I want in L1. And I'm going to go Second List, which is right above Stat, and I'm going to go Alpha T. And there it is, TXPRC. So I'm going to highlight that one there and hit Enter. And now I enter again, and those are all the textbook prices. So that is my response variable. And I'm going to write that down. I'm going to write L1 equals Y, that's my response, equals TXPRC. I have that on a piece of paper also so that I can remember that. Then I'm doing price versus pages. So I'm going to go over here to L2, and I go up to L2, and I hit Enter again. Hit Enter one. I'm going to go Second List, and now I'm looking for pages, and I think that one is just called Pages. So I'm going to go Alpha, and I'm going to go to P, and there it is right there, Pages. So L2 and equal L Pages, and I hit Enter. And you know, while I'm at it, I know that I'm going to need year. So I'm going to go up here to L3, and first thing I'm going to do is I'm going to clear it out. And now I'm going to go, so I'll hit Enter just so I know that it's cleared out. I'm going to go back to L3, Second List, and I want year, so I'm going to go, it's text year, TXYR, so second, nope, I did that, sorry. I'm going to go Alpha T, and there is TXYR, that's the one that I want. No, stop, TXYR. What's going on here? I'm not sure why this is doing it. It won't give it to me. Well, I don't know what that little glitch was, but I just started the process over again, and I got year now in L3. So my question is saying use technology to examine the scatter plot, price versus pages, and then price versus year. So I'm going to call up my calculator, and I'm going to go second stat plot. And the first thing I like to do is press 4 and turn them off so that I don't have any conflicts. So now I'm going to go second stat plot, and I'm going to go to plot 1. And if I'm doing price versus pages, pages is my X and price is my Y. So I'm going to turn it on. I'm going to go down, and I have the scatter plot icon highlighted. My list is in fact already L2, so I would put in L2 if I wanted to. So if there was nothing there, I would go second 2 for L2. And then my Y list is L1, so I would go, again, if I didn't have anything there, I would go second 1. And then I'm going to pick a mark, and I kind of like these tiny dots now. I didn't used to. And then I'm going to go zoom 9. And here's the scatter plot of price versus pages. What I'm going to do is I'm going to take a little picture of that, and I'm going to put it over here so that we can see it, so we can compare it easily to the next one that we're going to do. So the next one says compare it with a price versus year. So year is in L3, that's my new X value. So I'm going to go second stat plot, and I think I'll just use the same one, and I'll just change my X list from L2 to L3. So I'm going to go second 3. And I should be able to just go zoom 9 again, zoom, okay, it gives me that little funny thing on the bottom, which I can never figure out why it's doing. So I just hit the clear button, and now I can do zoom 9. And I would say that the first step, the first a scatter plot right here that we did looks a lot more linear and a lot more helpful than the second one. So I would say that the pages is going to be a better explanatory variable for price than year. In a minute, we'll find another way to measure that as well. So now they want me to find the least squares line for predict textbooks price based on its number of pages. Remember that another term for least squares line is the regression line. Both are the same. They mean the exact same thing. So I need to report the equation of this regression line and draw it on the scatter plot. So before we get into that, I just want to remind you of a couple things about the equation of a line. We're very used to the slope-intercept form of the equation of a line from algebra, maybe a little bit of pre-algebra. Y equals mx plus b. And m is the slope, and b is the y-intercept. Now, in stats, again, for some reason that I don't really know, we put it as y equals a plus bx. It's very similar. The b, though, is the slope, because you can see it's attached to the variable here, and the a is the y-intercept. And you will find this on your calculator. I'm going to call it the calculator. If you go stat, calc, now you'll see one that says number 4, linreg ax plus b. That's more similar to our mx plus b. But statisticians like to use this one down here, number 8. I'm getting there. Yep, there we go. Linreg, linear regression, a plus bx. So that's the one that we're going to use. That's the one that's going to give us the information that we need to draw the line, and it's also going to give us information on R, the correlation coefficient, and R squared. Now, if you start working on your calculator, you're going to want to go stat, and then over to calc, and then number 8 for the linreg. If you get something that looks like this, I don't like it. I like the old-fashioned, and this comes from the stat wizard. So if you get something that looks like this and you're following along with my video or you're in my class, what you want to do is press the mode button and then go all the way to the bottom and turn your stat wizard off. So I turn my stat wizards off, and now I'm going to go stat, calc, 8, and it looks more like I like it. Now, what you need to put in here, it's saying, the calculator is saying, okay, you want a linear regression, but what's the data? So you have to give it your x values and then your y values. X comes first, y comes second. So my x in this case is L2. Wrote that down. In fact, I can kind of take a look over here just so you see. See, I wrote it down. X, I'm looking at pages, and that is an x value. Year is also an x value, but I don't think I'm going to come back to that because it doesn't seem to be very helpful. Well, maybe we'll come back to it. But those are both x values. So I'm going to enter an L2, comma, L1. So let's go back to our problem here. So I'm going to go, I had stat calc linreg, and I'm going to go second 2, comma, second 1. And if I hit enter, well, I'm going to at least get the equation of the line. All I need to do is, if it's y equals a plus bx, I have the a and I have the b. But we can get a little more information out of this linreg function on the TI. And the way we do that, and you're going to want to know how to do this, is again press mode and go down to the bottom. And where it says stat diagnostics, I want you to turn that on. So I'm turning that on right now. And now I'm going to go back to stat, calc, 8 for Lynn Reg, and I'm going to go second 2, comma, second 1, and I hit enter, and it gives me my A, my B, my R squared, and my R. So that's a lot more information, and we're going to need it. I don't know why they don't make the stat diagnostics on the default, but they don't, so sometimes you have to go back and turn it back on. So the equation of my least squares line, my regression line, is this. Let's put it in this color here. I am predicting the price. So I go price hat. The hat means it's predicted. This is your Y value. And that is equal to A, which I have here as negative 3.42. I'm just rounding off. Plus B, my slope, 0.147 times pages. It is very important to make your variables understandable to people who would be reading them. Using X's and Y's is not really all that helpful. So if you're going to be a good statistician, you need to use variable names that make sense. So somebody could come up and look at this and say, oh, well, I'm measuring the price of something by pages, probably a book of some sort, so it kind of makes some sense to me already. So this is my equation for the regression line. But they're also saying to draw the line on the scatter plot. So we're going to learn a new trick for how to do that. I'm going to go stat, calc, and I'm going to pick 8 for my linear regression. And I'm going to do the same thing. I'm going to go second 2, comma, second 1, comma, and I'm going to add something now. I'm going to go alpha F4, which is right above the trace. It's the green button, and the green is the F4. And it gives me a list of all of my possible equation slots. So I'm going to press Y1, and I hit enter. So it looks L2, L1, comma, Y1. Now I'm going to do the calculation. I get the exact same numbers I had before, but what the calculator has done, which is really amazing, is if you go just to your Y equals, your graph, it has automatically entered the equation, even unrounded equation, into your Y1. Now, when I go to graph it, I'm going to go zoom 9. Whoops, sorry, my bad. See, this is good. I'm glad I made a mistake. I forgot to change my stat plot. So I'm going to go back to my stat plot, second stat plot. Remember, I did it with L3 and L1. Now I'm going to go back here and I'm going to change it to L2 because I want the same stat plot. So second 2, enter, and go zoom, clear that out, zoom 9. There's my original scat plot, and it draws my line of best fit. It draws my regression line. It draws my least squares line. Isn't that cool? That's like totally cool. Now the problem says, use this least squares line to predict the price of a 500-page textbook. Well, 500 pages is our input value. So if I want to do this, what I'm doing here is I'm predicting the price. So price hat is equal to negative 3.42 plus 0.147, and the number of pages we want is 500. So I can do two things here. One, I can do it on my calculator the long way. So I'm going to go second quit to get to my main screen, and I'm going to go negative 3.42. Whoops, it didn't come out right. Negative 3.42 plus 1.47 times 500. And it tells me that the predicted price of the textbook should be, well, that's a expensive textbook, really? $730.58. Maybe I made a mistake. Well, we'll find out in a minute. Another easier way to do it is to just go, since I have the equation in my calculator already, I'm going to go alpha F4. I'm going to select Y1. And so my calculator is saying, okay, you want me to do something with function Y1. What is it you want me to do? Well, I want you to evaluate that function for 500 pages. And I press enter, and I get a completely different number. And I get a number that makes more sense, don't I? I see my mistake. My mistake is right up here in this 1.47. It's 0.147. So let's try it again the long way. Negative 3.42 plus 0.147 times 500. Press enter. And I get essentially the same price. I get $70.08. When I did it into Y1, because the Y1 wasn't using any rounding, I get $7.24. Good enough. Want to be more accurate? Use the Y1 when the formula's been input. If you round off, that's okay too, close enough. And I will point out, you know, doing it both ways is kind of a way of checking your work, isn't it? Because $731 for a textbook sounded awfully expensive to me. So checking it with my Y1, then I was able to find my error pretty easily. So the next part says, identify and interpret the value of slope coefficient in the context of this study. So again, going back to our old algebra work, if you remember, if I had something like, 4x squared plus 3x minus 2, the coefficient is the number that's attached to the variable. So in this case, 4 is a coefficient, 3 is a coefficient. When we're talking about slope coefficient, we're thinking about y equals mx plus b. We're looking at the slope, the m. So the slope coefficient of our linear regression formula is this here, is 0.147. And what that is saying, and it's saying that for every change in my input variable of pages, my predicted price, my y variable, is going to change by 0.147. So sorry for that long pause. I've written it out here. For every 1 unit change in my input explanatory variable, my output response variable will change by 0.147. That is the value of the slope coefficient. Again, sorry for that long pause. Next, I need to determine and interpret the value of r squared in the context of this study. So I'm going to go back to my calculator again and just show you again, how do we find the R squared? We go stat, calc, 8 for linear regression, my x value, second 2, comma, second 1, hit enter, and I get my R squared of 0.6765. So let's just write that down here. 0.6765. One thing I want to point out to you here, and I'll just write down the R as well, 0.8225, is that I did this by doing stat, calc, 8, and I did L2, L1, but if I do second 1, comma, second 2, well, what you'll see is that my linear regression line has really changed. My A and my B, they don't look anything like they did before. But the R squared and the R are the same because the correlation coefficient doesn't matter. It's a correlation between the two variables. It doesn't matter which one's first and which one's second. It doesn't matter which one's X and which one's Y. They're the same. So interpreting this, this is my, my R squared, and you can see that it is just R squared. I like to think of it as deciding whether my correlation is very strong or moderate or weak. And really that depends on the context of the study. Because, you know, some studies I've seen where like an R squared will come out to be you know, like 0.17, and they'll say that's a very strong correlation because in the context of that study, it is. In the context of something like this, I would say that this is a moderate to strong correlation, and it's a positive correlation. We know that it's a positive correlation because our R is positive, and R squared is always going to be positive, and both of them are always going to be well, R is always going to be between 0 and 1. And R squared is always going to be between 0 and 1. R is always going to be between -1 and +1. Next, I have to make a residual plot. That will determine whether or not my linear regression is actually linear. So when you do the stat calc linear regression calculation, the calculator automatically creates a file which contains all of the residuals of that scatter plot. And what we want to do is we want to take the residuals versus our X values. So I'm going to go take my calculator here, and I'm going to go second stat plot. And again, I know my X values are in L2, so I'm going to hit enter right there, and that's my plot number 1. It's on. My X value is L2, so I'm going to get my Y value be the residuals. So I go second list, and I want to go to R, so I go alpha R, and I see my residuals are right there, and I hit enter. I'll hit enter again, get down to the mark, and now if I go zoom 9, I get, oh, I don't want the line, but I get a residual. Let's get rid of the line. Y equals, and let's just delete it, clear it. Let's go zoom 9 again. And I get a residual plot. And the residual plot should have no form whatsoever. It shouldn't be positive or negative. It shouldn't be linear. It shouldn't be curved. This one to me is actually a little bit sketchy because, I mean, usually it's a lot more random. This one to me looks like it could even be a little bit linear. But it's scattered enough to me that I would say it does justify the fact that my my original scatter plot is in fact of a linear form. So next they want me to determine the least squares line for price based on the year of publication. We saw that that scatter plot wasn't so great, but let's take a look at it. So I'm going to go least squares regression. I'm going to go stat, calc, linear regression. My X values now in my L3, second 3. My Y value remained in my L1. So I'm going to go second 1 and put a comma. I'm going to put that into my Y1 as well. Alpha, F4, Y1. And then I'm going to go enter. And one thing I find right here is that my R squared is only 0.186. That's compared to like 0.6 something for the other one. So clearly this is not as good of a correlation as is with pages, which we determined when we looked at the scatter plot as well. But I would like to see the residual plot for this. So I'm going to go second, stat plot. I'm going to hit enter. And instead of L2 as my X value, I'm going to use L3, which was the year of publication. And I'll go zoom 9. Again, I want to get rid of the line here. But you know, I got to say, this is quite disturbing to me a little bit, because this looks to me like a very random residual plot, which is telling me that that relation is linear. So I guess it's linear, but it just doesn't have as strong of a correlation as the other one. Sometimes you'll get a residual plot that has a very clear, say, a logarithmic shape or a parabolic shape, or a very clear linear shape, which if it has a shape, it indicates that your original correlation really isn't very linear. All right, it's a very thorough problem in linear regression and how to use the TI84 to find the things. Thanks.